I'll give a few words of introduction here. Yeah, my background is actually in academic philosophy, but I ended up here at the Public Health Agency working on data, and I'm very excited about it. I must confess, I do not know very much about R, so I'm a little bit, imposter syndrome here, but I know plenty about programming, and I picked up R relatively fast, so I think I have some things to show you here. But please feel free to correct me if I screw up a syntax or something like that. On the other hand, what I don't know in R, I do know about the Lakehouse, because that is my primary project here at CDPHE, is building that all out. And so my goal here is to really show you how R interacts with the Lakehouse and how you can make use of the Lakehouse with R. As we go, please feel free to raise your hand, ask any questions you may like. Happy to answer them. Or you can chat me and we can talk about it later, or whatever works for you. Okay, I don't know if I've seen everyone here before, so you may not even know what this Lakehouse thing even is. So I'll kind of give you a bit of a background on what is the goal of the project. And yeah, so mostly when I tell people what the goal is of the project is to aggregate health data and create a one-stop shop for analyses. And that's pretty much the big picture goal for non-tech folks. But since you guys are a little more techie, I think it's probably more appropriate to think of the goal of this project as creating a better data analytics environment for CDPHE. So that involves not just aggregating data from multiple sources, but also giving you all more freedom to do what you need to and get the right tools you need. So part of what we're doing is giving you a computer hosted in the cloud to which you have administrative rights and can install whatever you need to as you see fit. We're also giving you a database where you can create tables, run jobs, all that stuff that right now you may not be able to do in SQL servers that OIT runs. So that kind of freedom is part of the project to enhance our data capabilities. We're also creating like a collaborative environment where there are shared file structures that you can refer to in your code with other teammates rather than storing them perhaps locally. We are also creating additional computational resources so that you don't have to be limited by what your local laptop state-issued machine has. You can spin up cloud-based computers with like 64 gigs of RAM or whatever and do more heavy loads. And of course, we're centralizing all the data into a data model that is designed for analytics, not designed to run an application. So it should be a lot easier to query and work with. Cool. Any questions about those kind of high level goals? Okay. Cool. So let's see how we're even going to do this and how does R fit in. Well, one thing I want to note is that some of the things that we have done with R in the past, we can still do, but maybe now that you have more access, you might want a different tool. I'm not so sure, so we're not telling you what tool to use. Obviously, whatever you guys find most useful is the one you want to use. And I'll show you exactly how to get R to do those things here. So let's start. I'll just share my screen. And I should mention, we are still in development, so things are mildly imperfect in some spots, and we're still testing things out and improving them. Now, the first thing I want to point out is that virtual machine where you have admin rights and that collaborative environment. All of that is handled through an application in the Lakehouse called Core. So you can see it here, Collaborative Research Environment. So for this, you just log in and there you go. And you can see I've started mine already. I have a virtual machine control and my virtual machine status is running. So if I just click Open VM, in about 2 seconds, I can get into my computer. It's just a Windows box, but you can kind of see that it's inside my tab of my browser because this is a cloud-based computer run on Google's technology. Before we leave Core, I want to show you another side of it where that kind of computational resourcing and shared environment comes in. So you'll notice here I have an active workspace, and I just created a COVID test workspace for this. You can detach and attach different workspaces to your virtual machine. Now, these workspaces are kind of the hub for collaborative work. And I'll show you kind of a little how that works by just showing you, like, you can click like add workspace. So you provide a name, you associate it with an organization. And probably the most important parts are down here where you can assign a Jupyter Hub image. So 9 times out of 10, you'll just make it an RStudio notebook. So you can use RStudio in Jupyter Hub. And Jupyter Hub is that shared computational environment. Then you can assign it to either lab or studio. Again, 9 times out of 10, you'll want to put it on lab. And here you can assign what kind of computational resources you think are valuable. So what is the storage you want to have on this machine? What memory limit? It's 16 in the UAT environment, but it would be much higher in production. And how many cores you want. So depending on how much work you have to do, you can assign greater and smaller amounts of power to this. And if you'll see here, I have the COVID test project. Let's see, here it is. You can see how I've set it up. The storage is all local, so I didn't up that. And I have pretty basic level of memory, but I could have assigned more if I wanted to. And then the other side of this is there are people in this project. So right now I could, if I liked, let's see, I can add Nicole to this. Oh, you're not in my organization just yet, Nicole. So I will add Diane, but okay, so now everything I save in this workspace, Diane also has access to. And I'll show you a bit of how that looks like in the virtual machine. So this is the way you can share code, share data in a sort of safe environment. Okay, cool. I said you could ask questions, so I try not to pause too many times, but it's just my habit these days. Okay, so let's sort of get started into R. The first project I did was just opening up R, so that's pretty exciting. You want to double click on Jupyter Hub. Jupyter Hub is a technology that spins up computational resources. That's what you assigned over there in the project, and allows them to be shared by a team. You can just run RStudio on your local machine, just open up RStudio and you can get right to it. But by using Jupyter Hub, you allow for that sharing and increased power. Yeah, go ahead, Nicole.
Yeah, so when you say local machine, do you mean like the virtual machine environment that you're in right now? Okay, yeah, I just wanted to make sure, because this Jupyter concept's a little mind-boggling when you first learn about it, so I wanted to make sure it was clear.
Yeah, sorry, it's like local to my VM, but not local to my laptop, exactly, yes.
Right, great.
Okay, so you're in Jupyter Hub, you just got to sign in. So give it my name, give it my password, have it text me. And here I am. Okay, so sometimes you'll have to select your project, but here you can see the landing page and you'll see that URL/lab, just like we assigned on that project page. I assigned /lab because I wanted to show you all the things it can do. You can assign /RStudio and then it'll just like kick you right into RStudio without you having to do anything. So we have Python if you're interested, Julia, basic R, and then RStudio, which is where we will probably want to do our work. So just click on that one. The scheduling capacity, I should mention, one thing we wanted to build out is the capacity for automation and scheduling jobs. That should be released, within a week or something, and it will also be accessible here, is my understanding. Yeah, Jules, you're really famous. So, okay, so I'll show you the first bit of code here, and big thanks to Nicole, because this is a lot of this is just copied from her, but the BigQuery parts are mine. So here you can just see a set of packages. So I'll just run these and you can watch them come in. And I'll draw your attention to this last package, which is probably the new one and of the greatest importance. It's called Big R Query. So the Lakehouse databases are housed in Google BigQuery. So they're cloud-based. BigQuery is essentially Google's version of SQL Server. It's a big data technology, so it's like subtly different, but you can think of it as SQL Server. Yeah, so we have to find a way to connect R to that. There are a couple different packages. Big R Query seems to do a good job. There's others, though, if you're interested, and we can include them. One little wrinkle I want to mention, you notice I didn't install anything. I just ran these. The Jupyter Hub image comes with a base set of packages installed in it, and then you just bring them into your code via this kind of script, right? If you want to install new packages, you totally can. You just run the install script, very easy. But next time you start your script up, they will be wiped because they're not part of the base Jupyter Hub. If you do need any packages to be part of that main setup, you just let us know and we can add it to the list. But we've got a pretty extensive list so far, including some custom ones like the sysr one and so on. Yeah, go ahead, Nicole.
Yeah, there are some great ways to code out that. I think Julia actually did this at one point, where you can say, okay, is this package already installed? Then skip it and don't install it. There's some logic there you can put into the code. So that way, if you're automating it and it's just a weird package that you know you're only going to use for like one script and you don't need to be in your Jupyter space, that might be a better option.
Yeah, there's definitely easy fixes. And but if you're using it often, just tell us and we'll install it so you never have to worry about it. Pac-Man. Wow, R is really fun. Okay, so we have big R query. This next bit is not that exciting. This is, well, not exciting in that it's not new. It's probably pretty cool to you guys, but we just go to a URL. We pull it into a data frame using the read Socrata. Give that one a second to run. And then we're going to kind of do some manipulation. And the rest of this URL loading stuff essentially just takes this data frame, turns it into a cleaned up version that we like. And then we do it again for another URL with another set of data. We turn it into a set of cleaned up versions that we like. There's 2 of these. And you can see I've called them final df1, final df2, final df3, because I have a really big imagination. So down here now is the part where it's getting a little more interesting and you're able to see the BigQuery part. So first, in order to use BigRQuery, we have to authenticate. So it's actually super simple. You just write bq_auth and empty parentheses. The way we've set this up is when your user is created in the Lakehouse, we automatically create for you a service account that links your login with BigQuery and automatically authenticates you through Jupyter Hub. If you try to do this on the RStudio on the VM itself, you may have to like pass credentials or manually authenticate. So you can totally do that, but this allows you to automate the job because otherwise you'd have to like click, yes, it's me, and you can allow this. Going to set a few variables like the project ID and the dataset name. I'll show you where those are in a minute. The dataset is essentially the name of the database. The project ID is going to be almost always look just like this, except maybe prod for when we go to production. It's just the name of the overarching Google resource. Now, what I'm doing in the next, you see there's 3 kind of lumps, one for each of those data sets. What I do is I give the name of the data set with this line. Then this line creates a BigQuery table object for the BigRQuery script.
Hey, Kara, real quick, I think you might need to run line 70 again, or just make sure that the package is loaded for
oh, you're right.
BigQuery. Yeah.
I just kind of looked at it and I got excited. There we go. Okay, let's try that. Okay, there we go.
Yeah.
Appreciate that. Okay, so then we create a table object. We delete the existing one so that we have somewhere to create it easily, create the new one, and then upload all the data from our data frame to it. So I don't know how you usually do this, Nicole. I can go more into the depths of the methods and everything, and I'll share this code as well. Would that be valuable, or should we press forward?
We can share this code after today's discussion. I think typically when we're just like writing to the SQL Server, you can write it in one big line where you basically say like overwrite equals true. So it's not as many lines. So you're not typically deleting and then recreating and then uploading. It's all one line with the package that we use when we're just working with like a server that we're trying to write to. So it's just a little bit more expanded. but it looks like, I mean, it makes sense. You're just telling it what table, what project, and what data set. So for table, that's the table name in the BigQuery database, correct?
Yes, and I'll show you guys that in a second. Yeah.
Okay.
And there could well be a way to do this all in one line. I am still learning this BigQuery R or big R query package. Yeah, there may be more efficient methods as you guys are exploring. Okay, and then you do this again just for the rest, and you can see it in the output here. It's telling you like how much you uploaded, and we did it. Okay, so let's go see the fruits of our labors, and this will be sort of an introduction to the BigQuery part. So we can just open it in another tab. The RStudio is running in a browser window here. So go to BigQuery. Sure it's the right project. So we want to be in user acceptance testing. And over here, you can see this is that project ID, the CDPHE Lakehouse Infra UAT. You'll recall I passed that to the system up here. And then the Lakehouse stores data in a couple different places. There is the raw vault, where basically everything lands and it contains the entire history of all these records. There is the business vault, where things are a little cleaner and you only have the current records, so you don't have to sift through the history to find the data you care about. Probably this is the place to run most of your queries. And then you'll recall I mentioned we wanted to give you guys access to databases where you could run the show. And those are these different infomarts, which correspond roughly to different teams at CDPHE. So we have one for CDB, where COVID data usually lives. And you can see the three tables I created, one for HHS, another for admissions, and then one for daily. If you just click on these, it'll kind of kick up the schema, and you can query the table to make sure it did what you want. Make sure to put the star, and there it is. So we've got the states, the collection weeks, hospitalized, so on. Now all this data all this data is right here on the BigQuery instance. So you could join to it the data from EpiTracks that's in the business vault, for example, and write whatever queries you wanted. So in that way, this is sort of performing some of the functions that 144 does in the sense of collecting all your information in a single spot. Oh, cool. Does that make sense so far? Any questions?
Something that is sometimes useful for us, is there a way to see when the table was created? So see the last update date?
Yes, there should be. So over here in details, we have created, and that was 4 minutes ago.
Perfect. Okay.
Yeah, and then you have last modified. You can do a quick preview if you like. Probably should have done that instead of query it. There's also data quality rules, which I haven't shown you them here, but you can write data quality rules elsewhere in Google Cloud and have those apply to these tables, things like that. Yeah. Okay, cool. So that is pulling data into BigQuery from R. In this case, I pulled it from URLs. Nothing really stopping you from pulling it from some SFTP server or maybe even the Isilon file shares to which you can connect. There's definitely a lot of ways to get your data, and as soon as you get it into R, putting it into BigQuery is relatively trivial. Not just one line, I'm afraid, but I did it in 4. It's probably doable in less. Yeah.
It could just be a difference between the packages and the way that they're written. I imagine that's probably it.
Yeah, I agree. And there's probably like a BQ table update or something like that, and I didn't do that one. I kind of went through the conceptual steps because I wanted to make sure it worked. Yeah. Good. Okay, so we talked about getting data into BigQuery. Let's talk about now getting data out. So over here, I have a different one, quite simple again, only 3 libraries that I used. Again, you have to authenticate, and I'm passing, you can see the same parameters. Then what I did is I provided a basic query that just selects everything from a given table so that then I can manipulate what I got using dplyr. Now, before we go farther, I'm going to tell you a little more about this particular table I created because it's not the HHS one that we've just been talking about. So in the data lakehouse in BigQuery, the data that flows in comes from immunizations and epitracks. Of course, in the business vault, it is all stored in a format that is sort of designed for analytics, yes, but it is the data is segregated conceptually, right? So like person data is over here, person condition or event data is in another place, hospital data is in another place. Joining them is relatively simple, but if you wanted to get all of that into R at once, you could either write a big query and put it in your R script, or what we've typically recommended is instead create a view that always refreshes with that data and gives you a data set to work with that already includes just the variables you care about. So I've done that over here in my core disease set. I mean, this is really basic. I just pulled like some normal demographic information and some basic stuff about your condition. So you can create a view as well. Obviously, it's a view, so it's based on a query, and you can query. Let me show you the query I used. And if you go to details, you can find it. So you can then edit the query if you like, and you can kind of see what I did. I just, obviously, these are the variables I cared about. Over here, I have the joins I did. So I went from the person table up to a hub, to a link, to a hub, then down to the person condition table. I won't bore you guys with all the data modeling stuff right here now. We can talk about that maybe at another session. But because it's an analytical database, you don't have to do a bunch of lookups or anything to find the dashboard usable values for these things. But you do have to join a little bit to maintain that kind of elegance. So it ends up usually being a lot less joins than previous queries, but it might seem like just going from person to condition would be more intuitive. I just have to go through some of these. And I added a filter just that the disease has to be COVID. And I guess I probably shouldn't query this because you're recording it, and there's PII in there, so I'll let you go in there and take a look. Anyone who has access to this InfoMart, you can run the query and then see what's going on in there. Let me close these. All right, so I created this data set, and that's the one I'm going to point R to. And you can see I did that with this query, and I'm just selecting everything so that I can use dplyr and not have to think about SQL too hard. And then that's what I did. So this probably is the most interesting part of the code, because this is where I take it from that BigQuery database or table and bring it into R. So the first part here is I just write a query with the project ID, and then I pass it the query string from up here. And then I drop that into a table itself. So you have to do this table download, and then obviously I save that to the data frame. Does that make sense? I can go through it if you like. Yeah, go ahead, Nicole.
Yeah, is that like a period space in the BQ table download function?
It's, yeah, parentheses, period, parentheses.
Okay. And is that, so that just says create an empty table for which to place this in?
Yeah, like save the results of this query to this empty table, yeah.
Okay, okay.
I should note this table is stored in memory. It's stored as a data frame. It's not like on BigQuery now. Does that make sense?
So you can see it in the environment when you run it.
Yeah, exactly. Let me actually, why don't we clear these and then I can show you for just this script. So you run, you assign a few things, got your query, and now